So when I looked at the cool down results from the previous lesson, I saw that about 50% of them were able to write the function rule to represent the situation. I was okay with that because I knew that was one of the learning targets for today. So I knew that we were going to be working on that skill. And so I didn't need to do a whole lot of extra, maybe just emphasizing with that graphic organizer of how the rule comes about from 1 month, 2 months, 3 months, and looking at the pattern of the exponents and the repeated multiplication. I wanted to make that explicit. Beyond that, I didn't spend a whole lot of time because I knew we were going to be talking about that today. And then he did the bridge for this lesson that we saw today ahead of time. That was really focused on that percent change piece. And it was about 80% of students got that correct. I believe it was a growth and not a decay, if I remember correctly. And we saw the students got a little hung up on the decay today, which was not surprising. So that really let me know that I needed to focus most of my attention on figuring out the percent change from the decay factor and vice versa today. So the lesson is originally 90 minutes and we only had about 70 minutes to work with. And so what I did when I was planning is I looked at each question and each activity and I mapped it to the learning target. There was actually 4 learning targets for that lesson. That then was able to let me know that I could safely remove a couple of activities because learning targets were being met elsewhere. I was able to narrow it down because I had a variety of activities dealing with decay and growth, and I wanted to make sure both were represented in the lesson. So when I was carefully deciding which activity to lose, I was taking into account that I had a balance of decay and growth represented across the lesson. I was able to then kind of scoop in some of the discussion questions that would have happened in the activities that were skipped into the activities that I was planning to do. We're picking cards to see where we're sitting today. All right, look for the table. I think it's in the corner up, like near the window in the. All right. Chosen. You can just put that in the bucket of the table. Oh, you're right there. Major retailer has a staff of 6,400 employees for the holidays. After the holidays, they will decrease their staff by 30%. How many employees will they have? I know that timer is about to go off. When it does, just I don't know when the announcements are going to start, finish, whatever, but find a time to just connect with your partner and share your thinking, please. Thank you for being the first one to start that conversation. All right, so I'm going to go ahead and just reveal the answer. Check your paper. I saw it on a couple papers. 4,480. That's the number of employees that this particular retailer will have on staff after the holidays. So just double check that. When I was walking around, I saw a couple numbers above 6,400. I saw a couple of numbers that were below, but like well below. So check your work there. And as we go forward today, it's really helpful to just kind of soundboard off of your partner your thinking so that you can clarify, any missteps or misinterpretations. Okay. Okay. If you want to go ahead and open up your packet, we're going to go ahead and be in there. We're looking at the warm-up dandy discounts. And I want everyone to just take about a minute of quiet think time to think about the question that I have on the screen. All books at a bookstore are 25% off. Priya bought a book originally priced at $30. The cashier applied the store-wide discount and then took another 25% off for a coupon that Priya brought. If there was no sales tax, how much did Priya pay for the book? Okay, and then I, of course, show your reasoning. That's really important to show our thinking. So I'm going to go ahead and put 2 minutes on the clock. 1 minute will be just for quiet think time to ourselves, and then the next minute will be for you to share with your side-by-side partner. On the clock, 1 minute will be just for quiet think time to ourselves, and then the next minute will be for you to share with your side-by-side partner. All right, go ahead and turn to your partner if you haven't gone ahead and compared answers now. Specifically, I want you to compare strategies, so not just your answers, share your thinking. How'd you get there?
25%. Yeah.
Okay, so what I did was I added 25, and then you added, that would be 50, and 50% is half. So 32 divided by 2, 16.
5.
Of the information? I think it's a great place to start. I love it.
She corrected me.
What do you mean she corrected?
He took it, she was 50%, he was supposed to take it 25 and then do 25 again.
Oh, okay. So I love that. I'm gonna have y'all share that out here in a little bit, okay? So listen to her explanation, and I want you to be able to share that, okay?
Oh, you want me to share it?
So if
Okay.
y'all need to rehearse that, you can.
32.
Did you do it differently? Or what did you
No. 32.
How did you take 25% for your kid?
So like, if I went into 25%,
What did you take?
32, and then I
I
did
did not
36.
hear that. Okay, awesome. I'm gonna go ahead and stop us right here. Just curious, hands, who got $18? Just, okay, all right. A little bit less than what I thought when I was just walking around, but that's good feedback for me, okay? I did see a variety of things. So what was your name again, Dylan? Jacob, okay. So Jacob, can you talk us through what you did to arrive at this wonderful number 18?
It said the base price before tax was $72,
Okay.
and there was the store-wide discount of 25% off.
Okay, so talk about this, because 32 minus 25 is not 24. So talk me through what exactly you did to get to this 24 here.
32 minus 25% equals 24.
And how did you represent 25% when you did your calculation?
Just put it in minus 25%,
In what?
my calculator.
In your calculation. Okay, so I see a couple of different ways of looking at this. We can think about kind of 2 steps. What is 25% of the original price? Subtract that. So you've got multiplication, 25% of, and then you're doing the step of subtracting. That's 2 operations there. And then the other approach is a little bit more direct, and that if I'm taking off 25%, then really I'm paying 75% of the original price. And so I can just multiply by 75% or 0.75. You'll see the 2 pathways there for getting to the amounts that we are agreeing on. Okay. A little bit from y'all. We've got the 2 strategies on kind of similar to what's over here. Okay, so we've got that subtraction happening on the left, and then we've got just the simple multiplication on the right. We talked about the similarity. There's repetition going on. We're getting obviously the same answers, the 24 and the 18. How are they different? Someone summarize, how are they different? And then I heard one group talk about this, and this was lovely. Why is the price PREA paid not 50% of the original price? This group is talking about 50%. Can you explain why it's not 50% of the original price?
Because like you have to take off like 25 like more of the discount.
25%, so it's applied repeatedly. So 25% off of this, figure that out, 25% off of that. Awesome, thank you so much. We're gonna revisit that idea in the next activity, but I love that that surfaced over here organically. So thank you for talking about that. We've got, we're gonna go ahead and switch gears to activity 1. If you need to find your place in the packet, go ahead and do so. I'm gonna read you the top paragraph here. Tyler has a full tuition scholarship for the first year of college. To purchase books, they obtain a credit card and charge $450 for their books. However, they don't have the money to pay the credit card balance at this time. The credit card charges 18% interest monthly. The credit card accumulates interest on the unpaid balance monthly. How much will they owe at the end of 1 month? And assuming Tyler continues to make no payments to the credit card company, how much will they owe at the end of 2 months and 3 months? Okay, before we dig into those questions, I want to ask, what is this situation about? In a nutshell, if you had to sum it up in 1 sentence, what's going on?
Credit card,
Credit card, what do we know about credit cards?
they have a balance.
They have a balance, okay? Give me more, somebody else. Okay?
Remove that balance because of debt, and each month of the debt increases.
Ooh, I love that word debt, okay? So, I know a little bit about debt, college loans and things like that, right? That debt accumulates over time. There's this thing called interest, where you're basically paying the bank to have loaned you this money, right? For an extended period of time. Beautiful. Okay. So, what I want you to do is I want you to work collaboratively with your partners on just questions 1 and 2 for now. I'm going to put 3 minutes on the clock. Again, I want to hear y'all talking. I've got some goodies if y'all are talking it out. So please go ahead and get started.
The word accumulates. So we're adding on top of these words. Yeah. Oh, I love that. Oh, you're already moving to an accent. Okay, over. Can you do me a favor? Can you go right up on the board? We're gonna get to here on the later question, so don't erase that because you are like way ahead of the game right now. But just write down this part right here. Under strategy 2, that's the number 1. You can take accumulates is kind of in bold there, so we're owing more and more each time. Okay, that's that accumulation.
Good. Okay, so as I'm walking around, I'm hearing a lot of talk through around are we increasing in the amount we owe, or are we decreasing the amount we owe? There's a word that's kind of bolded there, and we talked about interest earlier, and I forgot your name. What's your name, darling? Say it again. Say it again. Kira. Okay, sorry. Kira was talking about like you're getting more and more in debt, and you're probably thinking like, well, debt means like we owe, debt means like we're in the negative, right? But there's a word that's bolded. What's bolded there?
Accumulates.
Accumulates. What does that make you think of?
Like,
Yeah, we're owing more and more, right? So yes, we're owing, but we're owing more and more. So that. Thinking about Miguel's strategy here. Okay, and Miguel, can you just talk briefly about why this works?
It says they charge them 450, so it's actually a starting point.
Starting point. Beautiful.
And for the 18% is actually 0.18. It's adding up.
So 0.18 is the 18%. What about the 1?
It's a whole amount of, full fee.
Ooh, I just heard over here, 100%. So we've got 100% plus 18% more on top of that. Yep, okay. Keep going with this strategy. I love Miguel's strategy here. Go ahead and figure out months 2 and 3. Let's start getting some actual amounts here that Tyler's owing as well, okay? So I'm gonna put, I'm not gonna put it on the board, but we've got 1 more minute, okay? 1 more minute.
You get a straight line for the next one,
So what are we doing with 18%? Okay, so you're adding it. So you're kind of doing that like strategy 1, where you're like figuring out what's the increase in this case, and then you're adding it. So you're doing it like in 2 steps. Can you go ahead and write that under strategy 1? Like show what you're doing.
then you have the extra one. You have to put,
You can use this marker here, okay?
under the strategy one box.
Right. That was for the first one, yes. And then all right. So we've got another strategy that's being shown for this particular problem. Just like in the last problem, we had 2 strategies, 2 approaches to setting this up. We're showing that second strategy now. And just double check, you got $531 is what Tyler owes after month 1, okay? All right, so looking at these 2 strategies, we've got kind of similar to what we saw in strategy 1 in the warm-up. We're taking like essentially 18% of 450. So if I were to like fully on write this out, I would say 450 plus 0.18 of 450, and I'm adding that to the 450, right? So this is, I'm doing 18% of 450, adding that amount to the 450. That's what's giving me 531. I know. What would you then do for month 2? What would you do then for month 2 if we're using this first strategy? Go ahead. Okay, so you're a little bit ahead of the game. We're gonna save that thought. I got a couple people that are a little bit ahead of the game, and I'm gonna have you show that out here in a second. You would just simply take this 450 and replace it with the 531. So now I have a balance of 531, and I'm going to figure out 18% of 531. Y'all see that repetition there, right? And then what's that amount? Did anyone get that amount after 2 months? Yeah. Yep. $626.58, okay? And then we would, again, 626, yay, plus 18% of that amount. Okay, so double check, you should wind up with $739.36. Yes? Okay. And I think we're right there on that function rule. Some of us have even written that function rule down. So we're really dancing around writing that function, which is one of our learning targets for today. I can write an exponential function to represent a situation. Okay, so that's wonderful that y'all write that. Questions 3 and 4, work with your partner. Both are acceptable. In this case, we're really symbols. That's a great question.
It's 18%.
So how we can apply it, how we're working on it.
All right, guys, we've seen some lovely things. Before we dive into the function rule. I just want to kind of show y'all the parallel between what's happening here, okay? So in number 3, y'all were looking at Tyler representing that 3 months, and he represented it using this strategy here that we already talked about, yes? So I'm just going to kind of copy that over here. We've got 450 times 1.18 times 1.18 times 1.18. Somebody asked me earlier, like, is it multiplication or parentheses? Both and, right? When you've got these parentheses with no operations noted between them, they are multiplication, correct? We're good there? Okay. And so if I had to write this as an expression, a numerical expression, what would that look like? 450 times 1.18 to the, anyone got a blue marker? Nobody else will read that. Okay, awesome. Okay, whew. All right, function rule. What did you get? Lewis, right? Louise, thank you. What did you get?
450
Uh-huh.
in parentheses 1.18.
1.18, okay,
And
to the x. Okay, and let's see why that works, okay? We're looking at this pattern here. If I wanted to know x months, then I would be doing 450 times 1.18 on repeat, right? For however many months, whatever x represents, correct? Okay, I don't know what x represents, okay, x months. So the way that I write this as an expression would be 450 times 1.18 to the, I don't know the number of months, so x, okay? That this pattern of repeatedly multiplying by 1.18 is what leads me to my function rule, okay? The wonderful thing about function rules is once you have them, then you can answer a whole lot of questions, okay? All right, so I'm gonna go ahead and pull up Desmos on this computer. Let's talk through what types of questions I could answer now that I know my function rule. Okay, so here is that y, you can see what I typed in, y equals 450 times 1.18 to the x power, or I could write f of x, right? They'll give me the same graph. One's in function notation, one's just an equation. Okay, this one's function notation. And the nice thing about having a model or a rule is I can answer a lot of questions. So for example, if I wanted to know how many months it would take for Tyler to owe $1,200, $1,200, what could I do? Oh, okay, so we could do that like y equals 1,200, and then what? So you see what happened here? Now I have like a horizontal line. What am I looking for there?
Where it crosses.
Where it crosses. Okay, so I'm clicking on that. Oh, great, I get an order pair, 5.92594, 1,200. What does that mean? How does that answer the question, when will Tyler owe $1,200? See Kira's hand, but I've heard Kira a lot. Somebody other than Louise or Kira. What would this do for me?
Oh,
Go
like
ahead.
after like the X amount of months.
After, I love that you said after the X amount of months, because in my ordered pair, the X is what would answer a question, yes? So this about 5.9, almost 6 months, let's call it 6 months, Tyler would be owing $1,200. You feel good about that? Give me a thumbs up. Okay, now here's the thing about a model. Models have limitations. They're limited by the assumptions that are made when making the model. We assumed that Tyler never pays off any of this debt at any point. He just lets it accumulate, right? At some point, he's gonna have to pay paying it off once he, at least at the last minute, would be when he graduates, gets his job, starts paying it off, maybe hopefully before then, yeah? Okay, so just keep in mind, models empower us to answer a lot of questions, but they have limitations based on what assumptions we make when we write the rules, okay? And I am going to read the prompt aloud for y'all that's on the screen here. Okay, this is activity 4, cancer treatment. Iodine 131 is used to treat thyroid cancer. The typical amount used in therapy is 150 millicuries. By the way, a millicurie is a unit used to measure radioactive materials. Iodine 131 decays at a rate of 8.3% each day. All right, so my question to you all is, what is this situation about? What is this, and take a minute to think about it. Take a brief minute to think about it. All right, let's hear it. What's the situation about?
The measurement and use the glucose.
Okay, treat what?
Thyroid
Okay. Measure of, what are they measuring? Millicuries, okay, so measure of, well, what is the millicurie? That's a unit of measure, so what are we actually measuring? Iodine, okay. Thyroid cancer, beautiful. Anyone want to add on to that at all? Go ahead, Karen. All right, hold on to that. I'm gonna come back to that. Thank you. But it's decaying. Let's write that. Yes. So this iodine decays. I'm gonna read it a second time. Actually, I want somebody else to read it. Miguel, I'm gonna have you read this. Miguel, can you please read the second time, for the second time, what's on the screen now? Okay, iodine 131 decays at a rate of 8.3% each day. Beautiful. Okay, and it's used to treat what? What are we treating? Thyroid cancer. Okay. All right. So, what are some quantities and relationships that we're seeing here? Kira, you alluded to one. What was the one you pointed out earlier?
No, it decreased by 8.3% each day.
Decreases by, what was it, 8.3% each day. I love that you included that entire statement. Decreases is important, that's a relationship. Each implies something, right? Per 1 day, okay? Each per 1 day. What is another quantity and a relationship that we're seeing in this prompt? A lot of information going on here. What do we need to process? What do you think? What have we missed? Beautiful. Typical amount, 450. I don't know if I can fit this long word in here. I did. Okay, millicuries. Any other quantities or relationships we need to be aware of? I love that y'all did not say 131. Why? Why am I happy that y'all didn't say 131?
Because it has nothing to do with it, it's the name of it.
Thank you so much. It's just the name. Y'all studied isotopes yet? If not, you will very soon in chemistry. Okay, it's just the name of the isotope of iodine. Okay, so it has nothing to do with the problem, and I'm glad we cleared that up because somebody might be thinking that. Okay. All right. So I want everyone to take a minute, read it again to yourself, and this time I'm going to ask you, what might we do to get started on questions 1 and 2. So you might want to go ahead and kind of preview questions 1 and 2 on your notebook, on your packet. What might we do to get started? I'm not looking for solutions, I'm looking for possible next steps.
you a minute to read it. Okay, so I'm here to like maybe move a decimal, because what does that do? Converts to decimal form, okay. Okay, alright, so possible subtraction to figure out, here I said it earlier, to figure out what's left. Okay, just a couple of ideas to get it started. Okay. Okay, I'm gonna put up some time on our clock. We're gonna go ahead and try to figure out what is that function rule. Somehow, is it gonna go? Maybe not. All right, let's pretend that that thing's going. 3 minutes on the clock. I'll monitor our time. You may absolutely work together. I'm seeing 150. You're seeing something else? Where? Oh, I did it right for You're good. Thank you. I'll correct that. Thank God, you're good. It's the one. It's the one you see. It's just me thinking of the last problem with the first.
Yeah.
One. Thinking of Tyler. Thank you.
You're welcome.
I wanted to say. Okay. So how do we figure out what? I think here's something about subtracting from 100. Start thinking about that a little bit. And that means that treatment is being completed really quickly, yes? Okay. So we gave it over there, great, but there might be some type of subtraction involved to figure out what's left. So it's not 80% is left of the treatment after each day. It's that 8.3% is being removed. So what's left? Think about that a little bit, okay? You might need a soundboard about your partners. I saw a few people that had the same thing written down. I'm just gonna write down what I saw y'all have. F of x equals, I think y'all said something like 150 times 1 minus 0.083. Someone confirmed that's what I saw when I was walking around to the x power. That's what you put? Okay. I saw like 3 or 4 people that had this. Some of you might have said something like f of x equals 150 times, is it 0.917? I saw that on a few papers as well. It's kind of split half and half. Y'all either had this 1 minus or this 0.917. I love the 1 minus because Lord knows I don't want to do that in my head if I don't want to, and I know Desmos will handle it, right? So I love that, and I love that it's kind of based on the 100%. So you're just removing the decaying portion, yes? Okay, and then this is that more efficient way to say that of, well, I know if I remove 8.3%, then I've got left 91.7%, so I can just write 0.917, okay? But I'm seeing both of these happening here. Okay. So y'all started to look at question 2. You weren't fully there yet. I want y'all to take about a minute, and I want you to, now that we know the rule, go ahead and type this in Desmos and start answering these questions in question number 2 with your partner, okay? Take about a minute.
You might have to play with your graphing window. Notice there's nothing on my graphing window yet. I'm kind of letting y'all figure that out a little bit. So don't be afraid to get your hands dirty and play with that graphing window.
So half the original.
Let me know if you need any help with that. That's fine. Just a little taste of questions to come. Chloe, can you tell me what graphing window y'all are using just so we can get that display on the board? 135, okay. And I'm gonna bump it up just a little bit higher, just so we can see that initial value. Remember 150 was our initial value, so I'm gonna go with 175. How we feel about that display? Does that work for y'all? Okay, so the first question was, after how many days will there be 100 millicuries of iodine 131? What do? I saw some horizontal lines being plotted. What was that horizontal line y'all plotted? Modeled it earlier in the last problem. Y equals what? After how many days will there be 100 millicuries of iodine? Y equals 100. Beautiful. All right. What does that show me? So I've got this ordered pair. How am I going to use it? The x value, thank you. So the x value is about 5, if I rounded up, right? So about 5 days, it looks like we'll be at 100 millicuries. Cool, okay. Question B, how many days does it take for there to be half of the original amount of iodine? Well, what's half of what? Half of the original amount, thank you. So half of 150 is 75, so y equals 75. What am I looking for on this graph again? Where are they, thank you, the intersection. Okay, so what's my answer there? 8, that x value again, beautiful. So after 8 days, we have half of that iodine 131 in our system. And then C, when will there be less than 10 millicuries? So what am I gonna type? Y equals 10. Okay, we're going further and further out on our x-axis, right? Because our x-axis is days, correct? Okay, I get this wonderful ordered pair. What are we thinking here? How many days?
31.
Yeah, after 31 days. Beautiful. Okay, when it is your turn and you've drawn that card, you got 2 things to do. You're going to figure out if the card is representing growth or decay. And the second thing you're going to do is you're going to interpret the meaning of the growth factor, that's the base of your exponent, in context. Okay, so what does this mean for the context that's on the card? Okay, so growth or decay, what does it mean in terms of context? The partner's job, that's not doing all the talking at that moment, is going to be what? Listening, active listening. Figure out if you agree or disagree with what's being shared, okay? If you disagree, I want y'all to hash it out. Math class is a perfect place to have some healthy debates, okay? Hash it out, figure it out, get on the same page, okay? It's good to have some disagreements every now and then. I want to hear that talking. I'll come around in a little minutes just to hear y'all talking some more, okay? And then I think on your paper you have like this little T-chart, so you can just like place the cards. I know there's not a whole lot of space, but just place the cards, whether in the growth column or in the decay column, okay? Let's just walk through an example real quick so we're all on the same page about how this is gonna work. Miguel, I'm gonna have you be my partner here, okay? Little improv, okay. So the card, we'll pick this card up, it says the function rule f of x equals 1500 times 1.21 to the x power, and it represents the amount of money owed on a credit card as a function of the number of years. So Miguel, ask me the question, the first bullet, ask me that question.
Does the next function have a growth or decay factor?
Thanks, Miguel, I'm glad you asked. I think that this function has a growth factor because the base of my exponent is greater than 1. So it's like 100% plus 21%. Okay, ask me the second question.
What does 1.21 mean?
Again, I'm glad you asked, Miguel. So in this situation, 1.21 means that the amount of money owed is increasing by 21% each year. Miguel, do you agree with that? Does that sound okay? Sounds okay? Awesome, okay. And then if you want to, you can use the sentence frame that's here, okay, if you want to. The blank factor is blank and means that the blank blank by a rate of blank each blank. You're probably like, what? Okay, this is how I would fit this all in. The growth factor is 1.21 and means that the amount of money owed increases by a rate of 21% each year. You'll see how I kind of fit all the blanks in there, okay? Don't have to use it. I know it's a little forced, but if you want to, you can, okay? I'm gonna put that sentence frame up on the wall here in a second because I'm gonna switch screens just to remind us of the steps. But otherwise, I think y'all can go ahead and begin. Here's a summary again of what we talked about, one person, second person, and then together work on an agreement and place the card accordingly. I'm gonna give us 6 minutes on the clock for this. All right, go ahead and begin.
6% every year after 1970.
So, yeah. The rate of 85.
Yeah.
Identical.
Okay, so mine is growth because it's 2 and it's bigger than 1.
Yeah.
I think about 8, so that's perfect.
I'm noticing the decay situations are where we're getting a little hung up. So we'll make sure we talk that out before moving on, okay? I think we've had enough time with the card sort. I'm just gonna go ahead and I want to talk through a couple of things here, okay? As I was walking around, this was a central question. How do you know if it's growth or decay? Take about 20 seconds, think to yourself. Then I'm gonna call on somebody to explain that to me. How do you know if your factor is a growth or decay factor? There's a standard number that we use. 100%, otherwise known as 1, okay? If the number's bigger than 1, are we talking about growth or decay? If the number's less than 1, what are we talking about? Beautiful, okay, there we go, that was what I was looking for. All right, so I've got this growth factor of 1.82. Again, it's a growth because it's bigger than 1, yes? Okay, how do I interpret that as a rate? Specifically, what percentage growth are we talking about here? 82%, okay, because we are a difference of 0.82 from 1. And 0.82 as a percentage is 82%. Okay, we were really getting hung up when I was walking around with card sort on the decay factors. Whew, okay, so we got a decay factor of 0.57. McKinley, help me out here. What do you think is going on with this? It is decay, okay? By what percent? You got this. So 57 is what remains, how much am I decreasing by as a percent? 43%. Talk me through, I don't see 43 there. What did you do mentally to get 0.57? You got this. What did you do? Alright. Rhiannon?
So it would be like the percent that you take away to get that.
Uh-huh.
So it's what's left out of 100 after you subtract that.
Okay.
Which is 43.
Yeah, so 100% minus 43% is 57%, and 57% is a decimal of 0.57. So it must have been 43%. Okay? This is exactly what I'm going to ask you to do on a cool down here in a second. So make sure that you can do this. We need to kind of rehearse that with a partner. Go ahead. Okay? You might be settling in. All right, when you do this cool down, I want you to do it independently. So this is the only time during the whole day I'm going to ask you not to talk to a partner. And then you can, yep, I see people going ahead and starting putting things back into the buckets. Yes, thank you for helping me clean up. Prioritize the cool down, but I can always clean up for you after that. And then clean up after that. So cool down first, and then you can clean up. We will be turning these cool downs in. Let's just say, hand it to me when you're done. I'll take it. Yeah, it'll say cool down at the top. That'll look right back to say cool down at the top. Reading this question, it doesn't ask them to say if it's increase or decrease. It just says to identify the percent increase or decrease. So I think we're just looking at these percentages. Hindsight, I wish we had said increase or decrease so that we can, have them clarify that. But I think we're okay. So this, I would say yes. This is medium. I love that they have that 0.518, but they're writing that 0.518 as a percent. So this is kind of like kind of there, kind of not. Yes. No. So this one, I'm not seeing anything. Looks like maybe they're trying to use the rule or apply the rule. That's kind of what it's, but it's not answering the question. These two work together. Okay, 4.92. Okay, this goes in that medium pile again, not subtracting from 100%. They see that there's a decrease, but just not doing that subtraction piece, which we knew was the hardest part for them in the lesson. Okay, this goes in the medium pile simply because they just didn't read the question correctly. They're supposed to be talking about the actual values. That's percent increase or decrease. They were able to say increase and decrease though, which is great. Okay. I would put this in the yes pile even though this number is not correct, and that's because we're not measuring on computation, but they knew to subtract from 100. So they knew the general idea of what to do, but they aren't, the computation just wasn't there. Okay. Medium pile again, decrease but didn't do the subtraction from 100. Similar to this, the computation wasn't there, but they understand generally what they're supposed to be doing. Okay, this is yes. Yes. This is that same situation, didn't subtract from 100. And this was, again, not reading the question, so they just did increase, decrease. There we go. Nice. So all but two in this column. Mm-hmm. Got some that are kind of there, mm-hmm. And it's like half and half there, splitting it evenly. Yeah. So this particular cool down is points to emphasize, which means that there might be a couple of at-bats coming up that are scooped into other learning targets where we could kind of reinforce these ideas, but we're not going to just have, you know, simple questions like this over and over again. It's just, you're going to have to kind of work it into lessons as we move forward. But it's not press pause, meaning like this is like the last chance to hit this learning target. So there are ways that we can hit this again. It looks like what this cool down guidance is suggesting is to potentially review a cool down with students in the next lesson. So what I would do is I'd probably take one from these middle stacks. Specifically, I'd probably take this one right here, and I would do a critique, correct, clarify routine. So I'd say, okay, what are y'all noticing about what the student wrote? Where's your critique? What would you clarify? It's going to be something to do with the fact that it's not supposed to be decreasing by 49%, but the complement of that if we subtract from 100%. And so I would do that critique, correct, clarify routine with students as like a warm up the next day, and then reinforce with practice problem 14 in lesson 9.